All right, this is going to be a rundown of a two-sample z-test for proportions. So here's the example. This year, the Carroll College Health Sciences Department studied a new flu vaccine in hopes that this year's flu season will be more under control than in past years. The company that developed the vaccine states that it will be effective or equally effective for men and women. So to test the claim of the drug company, so we are going to test this claim. The Carroll College Health Science researchers chose a simple random sample of 100 women and 200 men from the Carroll population. At the end of the semester, each person was given a binary score, 1 or 0, where 1 is equal to they caught a cold, or 0 is equal to they did not catch a cold. So based on the information that's in this spreadsheet, this is all of the data from that particular study, is there a difference between the proportion of women who become sick and the proportion of men who become sick? So this is what we'd like to do. This is going to be a two-sample test for proportions. So what we have here are men and women who either got sick or didn't. So this particular male did get sick. This particular male did not. This particular female did not. So let's start building some of our information. So since this is 1 and 0, to figure out the total number of people who actually got sick, we can just sum up all the 1s, so 1s and 0s, add them all up, we get all the 1s. So they got 108 total out of the 200 men. And so I can count all the numerical values in B. There's 200 men there. And I can do the same thing for the female. So let's sum up all of the people who got sick in the female columns and count all of the people in the female column. All right, so the proportion of people who got sick in the males is 108 out of 200, and the proportion of people who got sick in the females is the 66 out of 100. So what we want to test is the claim from the company who built the flu vaccine this year. So they say it's equally effective for men and women. So our null hypothesis is that there is no difference between men and women. I'm going to make this full screen here. So that's going to be our null hypothesis. All right, in symbols, that says P for men minus P for women is 0. The difference of the proportions is 0. Now, what we wanted to test is is there a difference between the two? So we're not saying men is greater than women or women is greater than men. We're just saying there is a difference. So the proportion for men minus the proportion for women is not 0. This is telling us we're doing a two-sample or a two-tailed test. Okay, so our assumed mean on the sampling proportion, this is 0. We are taking the difference between proportions. Our standard deviation is based on the proportions that we found. Now, it's based on sample information. No. Yes. Sorry, I confused myself there for a second. And if we go to our handy formula sheet, here we are. We are measuring the difference in proportions. Now, the men and women are not linked in any particular way. If they were linked, we actually need a different formula for this. That would be called a matched pairs test. These men and women are not linked with each other, so our formula for the standard deviation is here. So let's see if I can get these on the same page, at least close. All right, so here we go. This is equal to square root of, now I've got to be super careful about parentheses. Got first proportion times 1 minus first proportion over first sample size plus second proportion times parentheses 1 minus second proportion over that sample size and end my parentheses for the square root. So there's my standard deviation. Now, on our particular setup, we can take men minus women, so equals proportion for men minus proportion for women. It actually shows up to be negative because, of course, the proportion for women was actually higher in our particular sample. And then we say, okay, where is that as far as the z-score is concerned? So back to our handy formula sheet. The z-score is the number of standard deviations we are above or below the mean. So this is equal to our score minus 0 over standard deviation. Now that's on the left-hand side, but this is a two-tailed test. So if I'm doing a two-tailed test, I have to be a little bit careful. Let's scroll to the bottom and look at our two-tailed test. I'm going to be interested in this particular tail first, but then I'm going to double it because I want just the probability that there's a difference between men and women. So I am doing the left-hand side, and it is normal. So normal distribution. Now, I can go standard normal distribution because I actually just have the z-score, right? And remember that, oops, comma 1, cumulative always. Remember that the normal distribution and the t-distribution will always read to the left. And that's actually the tail that I'm interested in first, and I'm doubling it because I want the two-tailed test. So enter. Ooh, this one's interesting, 0.04. So at the alpha level 0.05, we reject the null hypothesis. In context, this means that we have sufficient evidence to believe that there is a difference between males and females with this particular vaccine. So again, I want to highlight one quirk that shows up with the two-tailed test, or the two-sample test for proportions, and that's in our formula sheet here. If we're measuring proportions that are not linked with each other, we are using this particular formula. If they're linked, you have to do something a little bit different, and that can be covered in a different video or at a different time. So I hope this has been helpful, and happy statisticking.